Have you ever looked up at the night sky and wondered what's really out there beyond what our eyes can see? Well, get ready to have your mind blown. The James Webb Space Telescope has just given us the most detailed, most expansive and deepest map of the universe ever created. This isn't just another pretty picture of space, it's a revolution in our understanding of the cosmos. Imagine looking back in time, not just a few years, but billions of years, to see the universe as it was in its infancy. That's what Webb is doing. This new map, a project called the Cosmos Web Survey, is like a cosmic census on a scale we've never seen before. Over just the first few months of observation, it has already imaged 500,000 galaxies. And that's just the beginning. By the time it's complete, we're talking about over 1 million galaxies. Let's put this into perspective. The Hubble Space Telescope, its legendary predecessor, gave us the iconic ultra-deep field image. It was a breathtaking look into a tiny patch of sky, revealing about 10,000 galaxies. It took Hubble years to build up that kind of data. Webb, with its incredible infrared vision and giant mirror, is doing this on a much grander scale and in a fraction of the time. The Cosmos Web Survey covers an area of the sky about the size of 3 full moons. It's like going from looking through a keyhole to opening a massive panoramic window onto the universe. So what are we seeing in this new map? We're seeing galaxies of all shapes, sizes and ages. Some are majestic spirals like our own Milky Way, while others are messy, chaotic collections of stars that are still in the process of forming. The most exciting part is that Webb is peering so far back in time that it's capturing the light from some of the very first galaxies to ever exist. These are the pioneers of the cosmos, the building blocks of everything that came after. They look different from modern galaxies. They're smaller, clumpier and more irregular. Studying them is like being an archaeologist, digging up the earliest settlements of a lost civilization. We're learning how galaxies grow, how they merge, and how the supermassive black holes at their centers evolve alongside them. One of the key technologies that makes this possible is Webb's ability to see in infrared light. As the universe expands, the light from distant objects gets stretched out, shifting from visible light into the infrared part of the spectrum. This is called redshift. The further away an object is, the more its light is redshifted. Hubble could see some of this, but Webb is an infrared specialist. It can see objects that are so far away, their light has been traveling for over 13 billion years. We're essentially seeing the universe when it was just a few 100 million years old. That's a tiny fraction of its current age of 13.8 billion years. It's the cosmic dawn, the moment the first stars switched on and began to illuminate the darkness. This Cosmos Web map isn't just about finding the most distant galaxies, though. It's about building a complete picture. Scientists are using this data to understand what's known as the cosmic web. This is the large-scale structure of the universe. A vast, intricate network of filaments made of gas and dark matter, with galaxies clustered at the intersections like cities on a giant celestial highway. By mapping out the positions of hundreds of thousands of galaxies, we can trace this invisible structure and understand how it guided the formation of everything we see today. Another mind-bending discovery coming from this survey is the sheer number of early galaxies. Current models of cosmology predicted we'd see a certain number of galaxies forming in the early universe, but Webb is finding way more than expected. They seem to be bigger and more developed than our theories allowed for. This is fantastic news for science. It means our understanding is incomplete, and there are new physics and new processes waiting to be discovered. It's forcing astronomers to go back to the drawing board and refine their models of how the universe began and evolved. Think about the questions this map helps us answer. How did the first stars form? How did they create the heavier elements that are necessary for planets and for life? How did supermassive black holes get so big so fast? These are some of the biggest questions in astronomy, and the data from the Cosmos Web Survey is providing the clues we need to start piecing together the answers. And it's not just about the distant universe. This incredible depth of field also allows us to study objects closer to home in unprecedented detail. Within our own galaxy, it can peer through dense clouds of dust to see newborn stars and planetary systems in the making. It's helping us understand our own cosmic neighborhood better than ever before. The project is a massive international collaboration involving hundreds of scientists from around the world. They're meticulously analyzing every pixel of data, cataloging galaxies, measuring their distances, and studying their properties. It's a treasure trove that will keep astronomers busy for decades to come. Each point of light in this map is a galaxy, a home to billions or even trillions of stars, and potentially countless planets. So the next time you feel small, remember this. We are part of an unimaginably vast and beautiful cosmos, and for the first time in human history, we have the tools to map it out and begin to understand our place within it. The James Webb Space Telescope's new map isn't just a scientific achievement. It's a profound new perspective on our universe and ourselves. It's a reminder of how much is still out there to explore and the incredible things we can achieve when we look up and wonder. What do you think is the most exciting discovery we might make with this new map? Let me know your thoughts in the comments below. Thanks so much for watching, and if you enjoyed this journey into the deep cosmos, don't forget to like this video and subscribe for more amazing stories from the universe. See you next time.